Hello, my dear students. Welcome back to the lecture. So once the bottom reinforcement is done, next we'll go with the top reinforcement. Okay. So this particular drawing, what we were referring, it was only for the bottom reinforcement. So it's written slab bottom reinforcement. Now we have to refer the next drawing, which is there. We already got the drawing. So it is written first, second, and third floor slab top reinforcement. So in the top reinforcement, you can see all this bar like this. See, actually, it's not properly given, but I'll draw it for you. Okay, because in few of the drawings they don't clearly mention, and in slab you should never expect to mention everything. Usually, when people do this thing, what is that? A drawing, they never write everything. In the slab, something we need to assume, something we need to apply our common sense. Okay, fine. So here now top you imagine wherever there is a beam column, wherever there is a beam, you will be providing a top reinforcement. That means, see, from here, one bar will be extended like this. From here, the bar will be extended like this. Okay, the bar will be extended like this. So in this way, wherever we have no, we'll be extending the bar. Similarly, like this, like this, like this. But it won't go full. Okay, why it won't go full? For a very same reason, it's a top reinforcement. Tell me how the bending moment diagram of a slab will look. It's similar to the beam, if you remember. Again, if I ask you to draw the bending moment, where is that? Yeah, okay. So if I ask you to do the bending moment diagram, so here we'll be having a negative bending moment. See why it is negative bending moment? Wherever there is a slab and a beam junction, you have a slab, you have a beam here. So in this junction, you'll be having a negative bending moment. Then it will be a sagging bending moment. Again, see here, beam and a slab junction, negative bending moment. Again positive, again negative. Got it? So wherever we have this kind of situation arises, so we are going to provide top reinforcement. Same thing on the other side. I did only one side. Here also same thing will happen. Again, you'll have a negative bending moment. You'll have a sagging, negative, sagging, and negative. Got it? On this side. So that is why we do all these things. So now, okay, okay. Ouch. Yeah. Okay, fine. So this side I did. Similarly, do we agree that we have to do on this side also? This side also we have to do. Again, this side also it will come like this. Okay. See the bar will be placed from beam inner to inner, from this point to this point. It won't come on the beam, and beam inner to beam inner. Okay. So this cutting length we want to find, and also this number of bar will find. This side we did. Similarly, in the center also it will be. See, center they have shown like this. No, center also it will be like this. Okay. This will be center. Because again, here negative bending moment will be there. Got it? This much you understood? Now, if you ask me, sir, what is the length of this? So, what is the length of this? So, what will be the length of this? For that, what we do? I'll just take a screenshot of this. Okay, and let me paste it here, else it will disappear. Yeah, so it will be given here. See, all the reinforcement will be given here. Bottom we already did. Right now we are at this particular stage. Bottom already we have done. This is a cross section. Okay, bottom we have done this thing. This is bottom, and whatever dot you can see, that was a distribution. I mean, bottom horizontal, bottom vertical. Now we are in the top. So top left, this is the distance what they have given. Top left from the beam outer to here. From the this is beam, okay, beam outer to here it is given this much you have to go. It is 1650. This was a middle span which I did on both the sides. So from the beam inner to this side it is 1650. From the beam inner to this it is 1550. And again this end it was C end, no? So from here it is okay. From this thing here it is how much? 1550. Got it? Able to understand? So in this way you are supposed to do the estimation. Okay, I mean bar bending schedule. Fine. So I hope you have understood the concept. So with this understanding, we'll try to find now. Yeah, top ring. So what I'll do, I'll go to the Excel sheet now, and I'll come here. Okay. So this is done. Now I'll start from here. So I've taken this particular shape. Yeah. One thing I wanted to tell. Last time I had shown you a few images. Okay. I'll show you that L shape now. I have a image ready for that. See here. This is a slab reinforcement. Okay. It will come. You can see this L shape. This is that L shape now. Got it, no? Again, see here, this L shape. I told you, no, I'll show you, I'll be showing you that. Okay, similarly, see here, this is that L shape. The bar has come from here, and from here you can see this L shape, it will be bent. Again, I'll show you another one image. In that, it will be very clear. Yeah, this image itself. Okay, you can see this L we have taken. Okay, this L we have taken. Huh. So again, we would be calculating our cutting length from here to here. That's it. That is from beam inner to beam inner. And after that, whatever we'll take, it is a development length. After that, what this bar will go, it won't go completely. So from here, the gap we are going to leave, that is 40 cm gap. So that means my bar will go only up to here. Okay. So this distance will be how much? Whatever is the width of your beam minus one cover, this length I'll get. And then I'll take this bend like this. This whatever bend you are able to see, you can see that bend practically here. See this particular area that bend has been put. So that height will be whatever is your slab thickness. This is my slab, no? So this is my slab. In the slab, the thickness will be given. So that top cover and minus bottom cover I'll do. Simple. Now it's understood, no? Finish. I'll go back. Yeah. So first I'll find the cutting length for this particular area. I'll want to find top left, this bar I'll find first. Okay. In this way, in this junction, A to B, 1 to 2 and 2 to 3. This much I'll find first. So how do I write? Very simple. How do I write? So I'll write at junction A because I'm conducting at a junction A and it is going along the grid 1, 2 and 3. Okay, remember that. So same thing I'll write. Top extra bar at junction A and in the grid 1, 2 and 3. Simple. And the shape will be like this. Again, understand. This bar, the top bar, you don't directly keep like this. The top bar will be kept in this way. How it's going to be? It will be straight like this up to here. Okay, up to here. And then from there, the development length. I mean, a bit. Let me do in this way. Yeah. So it will be like this, like this. And then it won't go completely. Up to here, we are going to stop it. Wait, okay. Sorry for that. I'll do one small changes. I'll do one small change here. And this will be a development length this much, and then it will be like this. So it will be something like this. The shape will be like this. Understand? The shape will be like this. So that is why I've drawn the same shape here. Where is that? Yeah. Wait. Yeah. So I've drawn the same shape here. So practically, if you ask me, sir, so shows practically, this is that what I'm trying to count. See here, top bar, no? This is top bar. It has gone straight. And here, it has gone straight up to here. This distance we'll calculate. Wait. This distance will calculate up to here. Wait. Okay. This distance will calculate. And after that, it will be my development length. This much will be development length and this. Got it? Whatever shape practically you are seeing now, whatever shape practically you are seeing, same shape I have shown. Other than that, this is a maximum explanation I can do. Okay. No one can teach you even better than this. Okay. Everything I have shown. Simple. This much is done. Okay. This shape I have drawn like this. Fine. Now I return top extra bar at junction A, grid 1 to C. So again, number of member is 1. Dia is 10. See, don't look at the dia and spacing. For all the calculation in the slab in this project, it is 10 diameter bar at 150. So 10 and 150 you do it. Now coming the cutting length. What is this cutting length? From here, the straight bar. This straight bar, how much it will go? So if you ask me, sir, how much it will go? So how much it is this magenta color? That for that you have to look into the cross section. So cross section, you have to look like this. See, now cross section you have to understand. These people have given ABC. We are looking like this, no ABC. So that means we are going to cut our slab in this way. I'll cut my slab from here. I'll cut my slab from here, and then from here I'll see. Okay, your section is cut here. So this is a YY section. So if I cut at YY section and if I see from here, I'll get to know what is this bar length. So for that, remember YY section. Come to the drawing. These people have mentioned YY section. So this is my YY section. Yeah. Can you see? YY section. And where is it? Yeah, this is YY section, no? Yeah. But we are at ABC. ABC, right? Wait, I have, see, always better try to have a hard copy of this. because every time switching in between the PDF will be difficult for you. So already I have a PDF. I have taken a soft copy of this. Okay. I mean hard copy of this, and you also do the same thing. Yeah, it is ABC. So this is that A, this is B, and this is C. So I want to find this. I want to know what is the length from here to here, from the face of the beam. Okay, this. So it is directly given 1650. Simple. And after that, this will be my, which will go in the beam minus cover, and then it will be given L. So in this drawing, actually, one thing I'll tell you, some may get confused. Don't look all this part. You just imagine that your beam is ending only up to here. Okay, your beam is ending up to here. Beam is ending up to here, and this part is something like this. Okay, this part will come and get bent here. Okay, the reason why it has extended is that if you observe the plan properly, there is a small cantilever slab coming, but I didn't consider the cantilever slabs because since we are doing it for the first time, I don't want to confuse you with all these things. And it's a very minor calculation we'll be doing. If you remember, see, this is actually a beam, isn't it? This is actually your beam. This is your beam. This is your beam. And this is your beam. And this is your beam. This is actually a slab what we consider. But practically, if you see here, these people have taken small offset here. You can see here, this offset these people have taken. So it's a small cantilever portion. Here also these people have taken. So it's a small cantilever portion. And here a small cantilever portion. So slightly your reinforcement will go outside like this. This is actually beam ending, but your reinforcement will go here. So that is why when you look into the cross-section part, these people are showing that also. But you don't consider, since I told it's a very small calculation, which is not required at this level. Since we are in the learning phase, again, if I teach you that also, it will be confusing. So that is why we can see this small, no, this is that cantilever portion. Okay, from this is your beam, from the beam that extended portion they have shown. But it's a very small portion, we will not consider that. And I told you we are doing a kind of estimation only in BBS also. Slightly, if you miss that, it's okay, since we are in the learning phase. Okay, real execution you have to consider, but now it's not required. Okay, got it? Fine. So this is 1650 we understood. That's it, simple. I have written 1650 directly. This straight is 1650. This is by default 275 because width of your beam is 300 minus 25 will be 275. And this L, this L, this L will be how much? Slab thickness is 160 minus top cover minus bottom cover. I'll get 120. And practically, if you ask me, this will be 120. This small, this much will be only 120. Okay, fine. That's it. Your answer is ready. So if you add everything, will you not get the cutting length? If you add all these things, if you add all these things, this and this, you'll get the cutting length of this bar. Very simple. So that is why we'll find. But only the catch here is that we need to find the number of bar. Now, how I'll find the number of bar? That is very important. So again, very simple. You know that. So finding the number of bar is very simple, sir, because we are going in this direction. We are going in this direction now. Since we are going here, we need to take this distance, sir, right? Agree with me? Which distance we are supposed to take? We're supposed to take this distance. And this distance, luckily or unluckily, it is given from center to center, but we need it from clear span. So 7500 is given, minus half beam from here, minus half beam from here. Again, minus the center beam. You're able to understand, no? Center, we are not putting any bar. So this center span also I need to deduct. Simple. This much you can do. 7500 minus 150 from here, minus 150 from here, and minus 300 from here. Whatever answer you get, you divide by the spacing and plus how much? 2. 1 plus 1 will come for this span. 1 plus 1 will come for this panel. So 1 and 1 is 2 we have to do. Same calculation, I have done it here. That's it. So number of bar what we did? Round up. Always remember round up. 3750 plus 3750 is 7500 minus 150 minus 150 minus 300 the center beam divided by the spacing. The spacing is 150. Whatever answer we got, we should take plus 2 because we are taking two spans simultaneously. So I've taken plus 2, close the bracket. I mean, give a comma 0, close the bracket, hit the enter button, finish. 48 number of bar is required. Finish. Cutting length you found. Number of bar is found. Next is very simple. So this cutting length will be 275 plus 1650 plus 120 will give me 2025. And cutting length in meter will be divided this by 1000, you get 2.025. And therefore total cutting length will be how much? Total cutting length will be cutting length of one member multiplied by number of bars into number of member will give me 97.2. And since it's a 10 diameter bar, I'll be putting the weight in the 10 diameter. So it comes out to be 97.2 into 0.617 will come out to be how much? 59.97. You just reduce the number. That's it. Keep it 3-digit. Done. Finish. We can do no. So again, the catch is we did only this portion now. We finished this portion. We finished this portion. Next, you tell me which portion you'll go. You have two options. Either you can come to the center portion. Come to the center portion. Wait, we have to go to the top, no? Yeah, this is bottom reinforcement. Yeah, we did this one. Okay. This is calculated. This is calculated. This is calculated. Everything we got. We found we have to provide 48 number of bar in this direction. And cutting length will be 2050 of this. Fine. Now you can come to the center and do the calculation. Else you can go to the corner and then you come to the center. It's totally up to you to decide which way you want to go. What I'll do is I'll go to the corner now. I'll find the cutting length for this bar, this bar. Same thing, okay? Again here, the bar won't be like this. Remember, the bar will be again something like this. Like this, the bar will come up to the beam and then that red color portion. Your development length will come. It will get like this. Got it, no? This is on this side now. Fine. So in this way, try to do this. Again, same thing. Number of bar will remain the same because you're going in the same direction, no? This is also 7,500 for this. When you're calculating for this, this is also 7,500. So number of bar remains same. Only the cutting length you check in the section how much it will come. I'll take you. So now I need to check here. So I'll go to the right. So I need to again see in this direction only. I need to check in which direction I need to cut my. See, if I want to see what is the reinforcement here, what I'll do, I'll cut the here and I'll see from the top front. Okay. So for this, yeah, yeah. If I want to check here, what we'll do, yeah, this side we are putting the reinforcement, no, yeah. So we have to check. Anyhow, this will not happen. Okay, bar is going in this direction only. Yeah, you have to check this only. Fine, come. So A, B, C we did. A, B we did. Now we are in the C junction. So in the C it is given 1550. How much? How much it is? 1550 from the face of the beam. So again 1550. Come here. See, I have written 1550. This remains same 275 because 300 minus 25 won't change. And this also will be 160 minus 20 minus 20 will be 120. Finish. So I've written top extra bar at C junction. So this is my C junction. No, this is my C junction along 1, 2, and 3 grade. So I written the same. I written the same thing here. 1, 2, 3. Again, everything remains same. Nothing will change. Only the cutting length. See, 110, 150, 48, 110, 150, 148. Because number of bar remains same on this side and this side. Only the cutting length you add. That's it. Which one? 1550 plus 275 plus 120. This will give me 1925 divided by 1000, 1.925. Total cutting length will be 1.925 multiplied by 48 into this one. And weight will come out to be how much? Weight will come out to be how much? Very simple. 92.4 multiplied by 10 diabar, which is 0.617. We'll get 57.011. Finish. So this side bar I did. This side bar I did. This side bar I did. Now I want to find the center portion. That's it. The last bar. Okay. This bar you want to find now. How you'll find? Very simple. Again, you have to go to the cross section where you need to check. At B grade, you check. They will give this section. This section will be shown. Check this section and tell me what is the diameter of the bar given. And then you just have to, again, the number of bar remains same because again, this length, and this length is same. So number of bar remains the same. 48 only will get. But only the thing is, come to the B section. So in the B section, it is given. From the face of the beam, on this side, you have to take 1650. Again, from the face, wait, I'll go with a different color. So this is 1650. Again, from this face to the right side, it is 1550. And this is 1650. Is it correct? If I add 1650 and 1550, will I get the cutting length? I'll get. But the problem is in the middle. Middle, you have a beam and the width of your beam. So you have a beam here in the middle. And the width of this beam is how much? 300 because beam width is 300 everywhere. So you'll be adding 300 also. So what will be your cutting length? 1650 plus 300 plus 1550. If you add everything, You'll get the straight length of this bar. The straight length you are going to get. Okay, that's it. If you do that, you'll get the cutting length of that. We'll go back to the Excel sheet. I've written it here. Top extra bar at B junction. No, this is my B junction. This is my B junction. Okay, great. So top extra bar at B junction on grid again 1, 2, 3. So this will be how much? See, 1650 plus 300 is the width of your beam plus 1550 is the on the right side. Finish. Number of bar I told it remains the same. 48 only we are getting. Cutting length will be directly 3500. So if you divide it by 1000, it will be 3.5 meter, and it will be 3.5 meter. And cutting length will be total cutting length is 3.5 into 48 into 1. If I do finish 168 meter, you'll get. And then the weight of 10 diameter bar is 168. If you multiply it by 0.617, you'll get 103.656 kg. Finish. So in this way, we have done the top extra bar. Finish. Now your calculation is still not done. If you remember, because this will take time, slab will take time to do the, but it's simple calculation. Now, if you remember, if I ask you everything we have done, yes, sir, everything we have done, this we did, this we did, okay, this we did, 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 and we found that 48 number. Then we came to the middle also. In the middle also, we found the number of bars, sir. This also we did, right? So this bar also we did, top bar. And here also, corner also we did. Everything we did, correct. Now, horizontally we did. Vertically we did not go. When I say vertically, you'll be providing extra bar in this direction also. In this bar also, in this side also, your extra bar will come. Right? In this direction also, your extra bar will come. Like this, it will go. In this direction also, your extra bar will come. In this direction also, your extra bar will come. I'm showing, okay? And then this is your middle. So here also, it will be like this. Getting my point? So when you do this, only then your slab will be completely ready. Got it? Now, if you want to, if you're asking me, sir, show this practically. See, this is how it looks practically once you finish everything. Where I can show you practically. If you can imagine, yeah, this will be something like that. See, right now, whatever we did, now we did only on this side. I mean, just now, whatever calculation was there, this calculation we did, and this calculation we did. If it was only one span. Okay, wait, anyhow, I'll show it on the two span only. Two span, yeah. Right now, what we did was this we did. We finished like this. One support we did. This was your which support? A support. Okay, great. Then we did on this support. Let us consider this support also we did. And then we did the middle support like this. Okay, finish. You can see in the middle practically how it has been done. Now see, this is one support, right side, this, and then the middle beam was added like we did. Getting my point? Practically, so you are able to see, finish. This much is done. But who will do on this side? This side also we are supposed to do, no? You can see practically this side also these people have done. This side also you have to do. And then this side also we are supposed to do. If it is two span, I'm telling. This side also we are supposed to do. That's it. So if you do all these things, your complete BBS will be ready. So if you can, if I can try to zoom in, see, like this, it will look. Here also you can see the bar, no? Anyhow, we'll show a different image for that. See here, this is what we completed. This one we are supposed to do, right? So in this way, see here, this one you can see, no? In this way, the bar has been placed in this way. You're able to get, no? I hope you're able to understand what I'm trying to tell. That we are supposed to get. So in the next lecture, I'll teach you those part. And after that, if you do that, BBS will be 90% done, but still another 10% is there. That again, in the next lecture, I'll teach you. Up to here, you practice it. Preparing the Excel sheet is very simple. Since you are prepared for the beam, there's nothing changes in that. Just you have to copy paste the format, and this kind of shapes you can easily prepare by now, because we are almost in the last phase of our BBS, last phase of our BBS lecture. So I hope by this time you have developed that skill. We'll see you back in the next lecture. Thank you.